Number one, given the triangle ABC, the sum of three angles in any triangle is always 180 degrees. Part A, find an angle alpha if A is 40 degrees. From the diagram, we see the left portion of the diagram as a small right triangle. This is A, this is alpha, and this is the right angle. A is 40 degrees. So alpha is the difference of 180 degrees and the sum of the A and D, or 180 degrees minus the sum of the 40 and 90 degrees. It returns alpha equals 50 degrees. Part B, find an alpha if alpha equals 2A. So A plus an angle alpha plus 90 degrees equals 180 degrees. And alpha is given to be 2A. So A plus 2A plus 90 degrees equals 180 degrees. 3A equals, subtract 90 both sides, 3A equals 90 degrees, or A equals 30 degrees. But the problem asks you to find an alpha. Therefore, an alpha equals double of A, or 2 times 30 degrees, or 60 degrees as an answer. Part C, find an angle A if B is 25 degrees and the sum of the alpha and beta angles is 110 degrees. From the diagram, angle B is 25 degrees. Alpha plus beta is 110. If you redraw the diagram, that would be something like this. So alpha plus beta is 110. The beta is 25 degrees. And we are looking for an angle A with the assumption that any triangle, the sum of all three angles will be 180 degrees. So A plus 110 plus 25 degrees equals 180 degrees. Or A plus 135 degrees equals 180 degrees. That will give A equals 180 minus 135, or 45 degrees as the answer. Next example, for the right triangle ABC, here's the key term, the right triangle. If an angle C is 90 degrees, the side B is 10, the side C is 26, find the side A. With the right triangle assumption, so we can apply the Pythagorean theorem. If you draw the triangle, angle C is 90 degrees. You name other two angles as A and B. The opposite to side A, opposite to an angle A is the side A with the lowercase a. Opposite to the angle B is the side lowercase b, similar to the C. If B is 10, C is 26, we are going to find A. Follow the Pythagorean theorem. A squared plus B squared equals C squared. The A is what we are looking for. The B squared, which is 10 squared. The C squared is 26 squared. Or A squared equals 26 squared minus 10 squared. Then get the number out. 26 squared is 676 minus 100, or 576. So A is the square root of 576. or 24. Next example, solve for x. Part A, Pythagorean theorem. The problem already gets started for you. For the right triangle, we have the two legs as x and x plus 1. The hypotenuse is 5. Follow the Pythagorean theorem. A squared plus b squared equals c squared. We usually have the right angle as an angle C. So this is C. So the legs, either one could be A or B. Okay. A squared or the x squared, b squared or x plus 1 quantity squared equals c squared or 5 squared. So we are going to find the value of x. That's the goal. So let's simplify. So x squared plus x plus 1 all squared, that's the perfect square. X plus 1 times x plus 1 equals 25. Simplify more by multiplying, distributing all terms. So we have x squared plus 2x plus 1 equals 25. Combine like terms, x squared becomes 2x squared plus 2x. Subtract 25 both sides becomes negative 24 equals 0. Factor 2 out as a common factor. 2 times quantity x squared plus x minus 12 equals 0. Factor the trinomial x squared plus x minus 12. X squared gives x times x. 12 could be a pair of the numbers 3 and 4. So let's see 3 and 4 because the difference is 1. The sum is positive 1, so the higher number has the same positive as the result, the same sign as the result. So we get the factor x minus 3 and x plus 4. So we solve for x. So x equals 3 and x equals negative 4 as the two result. For the side, we disregard the negative number. We keep the answer as a positive 3. Next one. Follow the same Pythagorean theorem because this is the right triangle. So a squared plus b squared equals c squared. The A is decided opposite to an angle A. The B is decided opposite to an angle B. The lowercase c is decided opposite to the angle C. The A squared or 5 squared, B is x, so x squared. The C is the quantity x plus 1 squared. Then your goal is to solve for x similar to the previous part. 5 squared is 25 plus x squared. The perfect square as we did already in the previous example. We should get x squared plus 2x plus 1. Then you can see x squared and x squared can be cancelled. We have 2x here, minus 1 both sides, so we get 24 on the left, 2x on the right. That gives you x equals 12. Next, we find the remaining sides of a 45, 45, 90 degrees triangle. Part A, if the shorter sides are each 1/4. Part B, the longest size is 3 times square root 2. From the diagram of the 45, 45, 90 degrees, you see the two legs, they are equal. Use the notation x and x, and the the hypotenuse is square root 2 times x, which based on the model. 1 square root 2. So the shortest sides is 1/4. That means the x equals 1/4. So the remaining side, or the hypotenuse, or the side C, or the remaining side, is square root 2 times x, or square root 2 times 1/4, or square root 2/4. Next part, the longest side is 3 times square root 2. The longest side is square root 2 times x. Is means equals 3 square root 2. Square root 2 cancel. Therefore, your x is 3 as the two shortest side. In the diagram, you would get 3, 3, and then 3 square root 2. And for the first part, if you draw the diagram and put the numbers in, the shortest side should be 1/4, 1/4, and the hypotenuse would be square root 2/4. Number 5, find the value of the R if AB is 1 and AD is 11. Put the numbers in. AD 11, AB is 1. If you redraw the triangle diagram, this would be the R. Let's redraw it. 11 here. This is R plus 1. This is R. That's the right angle. Your goal is to find R. So use the Pythagorean theorem. A squared plus B squared equals C squared. C squared is the longest, which is the quantity R plus 1 squared. Then the two shorter sides, 11 squared plus R squared. And then clean up. 11 squared is 121. R squared equals R squared plus 2R plus 1. R squared reduce. So your 2R equals 121 minus 1, or 120. That gives you R equals 60.